The sound of metal and plastic exploding across the conference room still echoes in my head. Lance Morrison's fist came down like a hammer on 8 months of my life's work, scattering precision-machined components across that polished mahogany table like confetti. My hybrid tooling prototype, the one that could revolutionize aerospace manufacturing, was now just expensive scrap metal rolling under chairs. "This is garbage," Lance announced to the room, his voice cutting through the shocked silence. He turned toward Rachel Stevens, the Boeing VP sitting at the head of the table, instantly shifting into that smooth MBA charm I'd watched him deploy countless times. "We'll start over with a real digital solution. I'm Jordan Matthews, by the way. 49 years old, been designing mechanical systems for 24 years. And I just watched my career get demolished in front of the one person who could have made it all worthwhile." The conference room felt smaller suddenly. That prototype represented everything I believed in. Hybrid mechanical digital systems that worked without constant software updates. Manufacturing solutions that didn't crash when the network went down. Technology that actually solved problems instead of creating new ones. Rachel Stevens hadn't said much during my presentation. Now she studied the scattered remains with an expression I couldn't read. Her eyes moved from the broken prototype to Lance's satisfied smirk, then finally to my face. "Can I have your contact?" she asked quietly. The request caught me completely off guard. I fumbled in my shirt pocket for one of those business cards I'd printed myself after Lance forgot to order them when I got my last promotion. My hands shook slightly as I handed it to her. Lance's smile faltered just a bit. "Rachel, I assure you our team will develop something much more aligned with Industry 4.0 standards. Jordan's approach is," he searched for the right dismissive term, "experimental. Impractical for modern manufacturing." Rachel pocketed my card without acknowledging his comment. "Thank you for your time today. I'll be in touch about next steps." Her words were professional, directed at everyone and no one. As the meeting broke up, I knelt on the floor, gathering what I could salvage. Each piece felt like picking up broken dreams. The titanium bearing assemblies I'd designed to run for 10 years without maintenance. The pressure-responsive joints that required no sensors or software. The modular framework that could be repaired with standard shop tools anywhere in the world. "Leave it," Lance said, standing over me once Boeing had left. "Maintenance will clean up." I looked up at him. "These are custom-machined parts. Parts for a project that's officially terminated," he replied, checking his Apple Watch. "The design review committee agreed with my assessment yesterday. We're moving forward with the full digital framework." Something clicked. "You never submitted my documentation to the committee. You told me the meeting was next week." Lance shrugged. "I made an executive decision to fast-track the process. Your design was never going to meet market requirements." He straightened his tie. "Take the rest of the day. Clear your head. Monday, you'll join Stephanie's team on the sensor integration project. A demotion, not even thinly disguised." So here's the thing about my background. I joined Precision Dynamics Corporation right out of Purdue, attracted by their reputation for solving real manufacturing problems. I'd spent 6 years in the Air Force maintaining aircraft systems, so I knew the difference between technology that worked and technology that looked impressive in PowerPoints. For 22 years, I'd been developing solutions that actually functioned in the real world. While everyone else chased the latest software trends, I focused on hybrid mechanical digital innovations that were reliable, cost-effective, and didn't require a computer science degree to maintain. The company had always valued that approach, until Lance arrived. Lance showed up 18 months ago as our new division VP, fresh Stanford MBA, 33 years old, with big ideas about digital transformation. He immediately established himself as someone who valued flash over function. He preferred solutions that looked good in boardroom presentations. Sleek, connected, buzzword compliant. The fact that such systems became expensive paperweights when networks failed was, in his view, an IT problem, not a design problem. Over those 18 months, I watched him systematically redirect resources away from proven mechanical approaches toward whatever digital trend was getting buzz in Harvard Business Review. Budget allocations that had supported my hybrid development for years suddenly got reassigned to AI integration projects that never quite delivered the promised results. My team started getting pulled into other initiatives. Key meetings happened without me being invited. When I raised concerns about abandoning mechanical solutions entirely, Lance would nod politely and explain that the company needed to modernize its thinking to stay competitive. The prototype destruction wasn't spontaneous rage, it was calculated elimination of everything that contradicted his digital-first vision. 3 days after that disaster, my personal phone rang with an unknown number. Jordan Matthews speaking. "This is Rachel Stevens from Boeing." Her voice was unmistakable. "I'd like to see more of your designs, privately. Finally, someone who might understand. I'm not sure how much I can share outside company channels." "I understand your position," she replied, "but I believe your approach has significant potential. Would you be willing to meet to discuss concepts only?" We arranged to meet at a small machine shop in the industrial district. I brought only my design notebook, nothing proprietary, nothing that would violate my employment contract, just concepts I could sketch freehand. When Rachel arrived, she introduced herself properly. She wasn't just any Boeing VP. She was head of manufacturing operations for their defense division, responsible for production systems that built everything from fighter jets to space capsules. "Your approach solves problems we've struggled with for years," she said, examining my sketches with the practiced eye of someone who understood manufacturing reality. "Digital systems are great until they're not. When a production line goes down because of a software glitch, we're talking millions of dollars per hour. Finally, someone who got it." "I can't develop this further without access to proper machining facilities," I said. "Use our pilot manufacturing lab," she interrupted, gesturing around the space. "I'm hosting the Great Lakes Manufacturing Expo next month in Detroit. Every major aerospace contractor will be there. I want you to demonstrate what's possible. The Great Lakes Manufacturing Expo. Lance would definitely be there representing Precision Dynamics." "Lance will be there," I said. Rachel's expression remained neutral. "Yes. Your VP has been invited. Does that concern you?" It should have terrified me, but looking at the opportunity before me, the chance to finally show what I knew was possible, something hardened inside me, a resolve I hadn't felt in years. "Not anymore," I answered. And that's when everything changed. For the next 3 weeks, I lived a double life that would have made any spy proud. During the day, I worked on Stephanie Parker's team, dutifully running sensor diagnostics and keeping my head down. Lance grew increasingly smug, assuming I'd learned my place and accepted my demotion gracefully. What he didn't know was that my nights and weekends belonged to Boeing. Rachel had given me access to their pilot manufacturing lab in a nondescript building about 20 minutes from Precision Dynamics. The facility wasn't as flashy as our corporate headquarters, but it had something more valuable: machinists who regularly maintained production equipment under real-world conditions, not the pristine laboratory environments Lance preferred to imagine. "This bearing design looks good on paper," said Keith Bradley, a shop floor specialist who'd been troubleshooting manufacturing equipment for 15 years. He was examining my original prototype plans. "But this joint here, it seizes up constantly in actual use. Metal shavings get trapped right here and lock everything up. That kind of feedback was gold." Keith wasn't trying to impress anyone with theoretical knowledge. He was telling me what actually broke in the field. I redesigned that joint that same night, creating a self-clearing system that could handle contamination without stopping production. By the end of the first week, I had 3 major improvements that never would have occurred to me in Precision Dynamics' clean room environment. The Boeing lab operated differently than anywhere I'd worked before. Engineers and machinists collaborated as equals. Nobody cared about hierarchy or credentials. If you had a good idea that solved a real problem, they listened. If your solution failed under real conditions, they told you straight up. "Your pressure compensation system is brilliant," said Amanda Wells, a manufacturing engineer who specialized in aerospace tolerances. "But can you make it work when the ambient temperature swings 40 degrees during a shift?" I couldn't initially. But that challenge led me to develop a thermal expansion compensation mechanism that was actually better than my original design. Each conversation taught me something new about the conditions my systems would face. Not the controlled environments of laboratory testing, but the harsh realities of factory floors where temperature swings, vibration, dust, and human error were daily facts of life. Meanwhile, back at Precision Dynamics, Lance was busy preparing for the expo with his own agenda. I overheard him on a conference call one afternoon, pitching our revolutionary digital manufacturing initiative to potential clients. "We've completely moved beyond mechanical solutions," he was saying. "Our research showed that hybrid approaches simply can't deliver the precision and reliability modern aerospace demands." Our research, my research, that he'd just dismissed and destroyed. Stephanie noticed my reaction. "You okay, Jordan?" "Fine," I said. "Just thinking through some optimization problems." She studied my face. "You know, a lot of us were surprised when your project got canceled. The mechanical approach made sense for a lot of applications. Lance knows what's best for the market," I replied diplomatically. But Stephanie wasn't buying it. Maybe. Or maybe he just knows what looks good in PowerPoint presentations. The comment hung in the air between us. I was learning that Lance's digital-first mandate wasn't as popular with the engineering team as he believed. People who actually built things understood the value of solutions that worked without network connections and software updates. 3 days before the expo, I had my breakthrough moment. I was working late in the Boeing lab, fine-tuning the hybrid positioning system that had become the centerpiece of my rebuilt prototype. The mechanism needed to maintain micron-level precision while operating in environments where digital sensors would fail within hours. The solution came from an unexpected source. Keith mentioned that old mechanical gauges in automotive plants often outlasted their digital replacements by decades. "Sometimes the simplest approach is the most reliable," he said. That comment sparked an idea for a purely mechanical feedback loop that could achieve the precision of electronic systems without any of the failure modes. By midnight, I had a working prototype that exceeded the performance specifications of systems costing 3 times as much. "This changes everything," Rachel said when I demonstrated it the next morning. "This level of precision from a mechanical system? Our production managers are going to love this." The Boeing lab had become more than a workspace. It was a reminder of why I'd become an engineer in the first place. Not to impress people in meetings, but to solve real problems that mattered. Every day brought new challenges that made the final product better. By the night before the expo, I was looking at not just my rebuilt original design, but 4 additional prototypes addressing different manufacturing challenges, all functioning without network dependencies, all maintainable with standard tools, all built for roughly half the cost of digital equivalents. "Ready for tomorrow?" Rachel asked, stopping by for a final check. I ran my hand along the main assembly, a hybrid positioning system that could achieve precision measurements while operating in conditions that would destroy electronic alternatives. "I've been ready for this for 24 years. I just needed the right opportunity. And someone willing to listen," she added. The irony wasn't lost on me. For 18 months, Lance had been telling me the market didn't want mechanical solutions. But here was Boeing, one of the most demanding customers in aerospace, actively seeking exactly what I'd been developing. The morning of the expo arrived gray and cold, typical October weather in Detroit. I loaded my prototypes into a rented van, each one carefully secured in custom foam padding. The drive to Cobo Center felt surreal. 6 months ago, I'd been the senior engineer leading mechanical innovation at Precision Dynamics. Now I was essentially a contractor, preparing to demonstrate technology that my own company had rejected. I'd called in sick to work, sending Stephanie a brief message about a family emergency. The lie tasted bitter, but necessary. At Cobo Center, Rachel's team had prepared a demonstration space that looked professional but understated. No flashy graphics or digital displays, just clean work surfaces where the prototypes could speak for themselves. "The partition walls will stay up until your presentation," Rachel explained. "We want the full reveal to have maximum impact." As morning turned to afternoon, I could hear the expo coming to life beyond those partition walls. Industry voices I recognized, company names being called out, the familiar buzz of engineers discussing technical specifications and business opportunities. Somewhere in that crowd, Lance was representing Precision Dynamics with his digital transformation message. He had no idea what was waiting for him behind those partition walls. At 1:45, Rachel found me making final adjustments to the main prototype. "It's time," she said simply. "Let's do this." At exactly 2 o'clock, Rachel stepped onto the small presentation stage at the center of Cobo Center. The crowd quieted as she welcomed everyone to Boeing's Special Innovation Showcase. I stood behind the partition walls, listening to 300 industry professionals settle into their seats. Today is about solutions that work in the real world, Rachel's voice carried clearly through the space. Not technology for its own sake, but innovations that function when everything else fails. Through a gap in the partitions, I could see the audience. Manufacturing engineers, procurement managers, and executives from across the aerospace industry. People who understood the difference between impressive demonstrations and systems that actually delivered results day after day. My gaze found Lance in the crowd, sitting with the Precision Dynamics delegation about halfway back. He looked relaxed, probably expecting another routine vendor presentation. He had no idea what was coming. Our first demonstration embodies that philosophy, Rachel continued. Please welcome mechanical design engineer Jordan Matthews. The partition walls rolled back smoothly, revealing my 4 prototypes arranged on pristine white work surfaces. The crowd's murmur shifted in tone as people recognized that these weren't the typical digital systems dominating the industry. I stepped forward, my voice steadier than I'd expected. These systems address different manufacturing challenges, but they share core principles. They function without network connectivity. They maintain precision under real-world conditions. And they can be manufactured for 60% less than digital equivalents. Lance's face in the crowd was priceless. The shock, the confusion, the dawning realization that his former subordinate was presenting technology he'd publicly dismissed as obsolete. I savored that expression for exactly 1 heartbeat before turning my attention to the wider audience. Let me show you what mechanical precision looks like in 2024. I moved to the hybrid positioning system, the centerpiece of my demonstration. This mechanism maintains micron-level accuracy in environments where electronic sensors fail within hours. No software updates, no network dependencies, no specialized maintenance requirements. I activated the system, showing how it automatically compensated for vibration, temperature changes, and contamination. Then I invited Tom Richardson, a manufacturing manager from Lockheed, to test it himself. This is impossible, he said, watching the mechanical feedback loops adjust in real time. How are you getting this level of precision without encoders? I explained the purely mechanical feedback system Keith had inspired, demonstrating how ancient gauge principles could achieve modern performance standards. The crowd leaned forward, genuinely intrigued. Questions started flowing immediately. What's the maintenance schedule? How does it handle thermal expansion? What's the failure mode analysis look like? I answered each one methodically, showing how mechanical solutions could address problems that stumped digital systems. When someone asked about manufacturing costs, I pulled out actual production estimates that Rachel's team had verified. These systems can be built for 40 to 60% less than electronic equivalents, I explained, and they'll operate reliably for 10 to 15 years without major maintenance. The crowd was engaged now. Business cards started appearing. A Northrop Grumman procurement official asked about licensing availability. A General Dynamics engineer wanted detailed specifications. From the corner of my eye, I saw Lance attempting to push through the crowd toward the front. His earlier shock had transformed into something more calculating, more desperate. "Excuse me," Lance's voice cut through the discussion as he finally reached the demonstration area. "I think there's been some confusion here." The crowd turned toward him with mild irritation. This was their time to evaluate technology, not witness corporate drama. "Jordan is a Precision Dynamics employee," Lance continued, his MBA smile firmly in place. "These designs incorporate proprietary technologies developed under company resources. This demonstration wasn't authorized by our legal department." A ripple of uncomfortable silence spread through the audience. Rachel stepped forward smoothly. "Actually, that's incorrect," she said, her voice carrying the authority of someone who dealt with corporate posturing for decades. "These prototypes were developed entirely using Boeing resources, based on conceptual work that predates Mr. Matthews' employment at Precision Dynamics." She gestured toward me. "Jordan, would you mind sharing the timeline?" "The core mechanical approaches were outlined in my master's thesis from 1999, I replied, addressing the crowd rather than Lance. "I've been refining these concepts for 24 years, most recently in collaboration with Boeing's manufacturing team." Lance's confident expression wavered. Any similar developments would have been substantially influenced by proprietary methodologies from our research division. "Which methodologies specifically? asked Dr. Sarah Kim, a well-respected industry consultant who'd been following the exchange with professional interest. Lance opened his mouth, then closed it. He couldn't specify proprietary methods without revealing that he'd never actually understood the technical details of my work. Furthermore, Rachel added, consulting her tablet, we've reviewed Mr. Matthews' original academic work. The mechanical principles demonstrated today are clearly documented in his 1999 thesis, years before his employment at Precision Dynamics. The crowd was getting restless. Engineers didn't have patience for legal posturing when they were trying to evaluate technical solutions. Maybe we could continue the technical discussion, suggested the Lockheed representative. I'd like to understand the torque specifications for the positioning mechanism. Lance found himself pushed to the periphery as the conversation returned to engineering details. I spent the next 30 minutes answering technical questions, demonstrating failure modes, and explaining maintenance procedures. By the time the formal presentation ended, I had a stack of business cards and preliminary interest from 6 major contractors. The Boeing partnership had validated my approach in a way that 24 years of corporate employment never had. As the crowd began to disperse, I noticed Brett Sullivan approaching. The 68-year-old founder of Precision Dynamics moved slowly but with unmistakable authority. Lance spotted him at the same time and quickly moved to intercept. Brett, there's been a serious misunderstanding here, Lance began. Jordan presented proprietary technology without authorization. We need to discuss intellectual property protection immediately. Brett studied the prototypes with the eye of someone who'd spent 40 years solving manufacturing problems. Interesting work, Jordan, especially since Lance told me last month that mechanical approaches like this were outdated and impractical. The statement hung in the air like a challenge. When exactly did you make that assessment, Lance? Brett asked. Lance's carefully maintained composure finally cracked. I was providing strategic overview based on market analysis. You specifically cited mechanical precision systems as a failed experimental pathway that Precision Dynamics had abandoned, Brett continued. You presented this as concluded research during our board meeting. There may have been some miscommunication about attribution, Lance said weakly. Brett's expression hardened. Miscommunication. I see. He turned to Rachel. Ms. Stevens, I believe we need to discuss this situation privately. All of us. Rachel nodded. My office is 20 minutes away. Shall we continue this conversation there? As we prepared to leave Cobo Center, I realized the day had shifted from professional vindication to something much more significant. The confrontation I'd been avoiding for 18 months was finally here. But this time, I wasn't standing alone. Rachel's office at Boeing overlooked the Detroit River, gray water reflecting the overcast sky. The conference table could seat 12, but only 5 of us were present. Rachel, Brett Sullivan, Amanda Wells from Precision Dynamics Legal Department, Lance, and me. Brett wasted no time on pleasantries. I built Precision Dynamics to solve manufacturing problems, not to suppress innovations that serve our industry. I want to understand exactly what happened here. Amanda opened her laptop. We have documentation concerns. If Jordan developed these prototypes using proprietary knowledge gained during his employment. Let me stop you there, Rachel interrupted, sliding a tablet across the table. We've reviewed Jordan's master's thesis from 1999. The mechanical principles demonstrated today are clearly documented, including stress calculations and prototype specifications. Amanda studied the screen, her expression neutral but focused. Brett leaned over to look as well. The adaptive pressure system, Brett said, pointing to a specific diagram. This is identical to what Lance presented to our board as a failed experimental approach. Lance shifted uncomfortably. There may have been some overlap in conceptual frameworks. Overlap? Brett's voice carried decades of authority. You told the board that Precision Dynamics had explored mechanical solutions and determined them to be inferior to digital alternatives. You presented this as concluded research under your direction. I was providing strategic context based on market analysis, Lance replied, but his confident MBA tone was cracking. Rachel consulted her own notes. That's interesting because at last month's Manufacturing Innovation Summit in Chicago, Lance gave a presentation titled Why Mechanical Solutions Failed, a case study in digital transformation. He specifically cited Jordan's work as an example of outdated thinking that his team had abandoned. The silence in the room was deafening. Amanda looked up from the tablet, her face carefully neutral. Brett, I need to review this presentation. If attribution was misrepresented. I have the slides and transcript, Rachel said, producing another device. Lance repeatedly used phrases like, "my early research," and "our team's exploration" when referring to concepts that appear in Jordan's 1999 thesis. Lance's face had gone pale. Presentation environments require simplification. Attribution sometimes becomes, "You claimed credit for work you'd never done," Brett stated flatly, then used that false claim to justify terminating the actual innovator's project. I finally spoke up. This wasn't just about attribution. For 18 months, Lance systematically redirected resources away from mechanical solutions, excluded experienced engineers from planning meetings, and misrepresented proven approaches to leadership. "Can you document these patterns?" Amanda asked. "Check budget allocation reports for mechanical engineering versus digital initiatives," I suggested. "Compare project completion rates. Review meeting minutes for resource allocation decisions." Brett turned to Lance. "You were hired to expand our manufacturing capabilities, to identify innovations that solve real industry problems. Instead, you've been suppressing exactly the work we should be developing." "The industry is moving toward digital solutions," Lance insisted, grasping for his original argument. "Our investors expect modern approaches that align with current market trends." Jordan's demonstration today generated interest from 6 major aerospace contractors, Rachel pointed out. "Boeing is prepared to offer a development contract based on what we've seen. How does that align with your market analysis?" Lance's shoulders sagged slightly. The polished confidence that had defined his leadership style was evaporating under scrutiny. Brett stood up, his decision clearly made. "Amanda, prepare separation paperwork. Lance's employment with Precision Dynamics is terminated, effective immediately." "Brett, this is an overreaction," Lance said, desperation creeping into his voice. "We can work through these attribution issues. The important thing is moving forward with solutions that serve our clients." "Moving forward," Brett agreed. "Without managers who claim credit for work they didn't do and terminate projects they don't understand." He turned to me. "Jordan, I'd like to offer you the position of Director of Hybrid Manufacturing Technologies. You'll report directly to me with full authority over technical direction and team composition." The offer exceeded anything I'd imagined possible, but I'd learned to be careful about corporate promises. I'd need written assurance of resource allocation and direct access to senior leadership when technical issues arise, I said. "Done," Brett replied without hesitation. "Rachel, I assume Boeing's partnership offer is serious?" Rachel nodded. "We're prepared to commit $1.8 million over 2 years for hybrid system development, with production licensing options based on performance milestones." Lance was escorted from the building within the hour. Amanda handled the termination paperwork with professional efficiency, while Brett and I discussed implementation timelines for the new hybrid manufacturing division. "I want you to build a team that understands both mechanical precision and real-world manufacturing constraints," Brett said. "No more PowerPoint engineering, solutions that work when everything else fails." The Boeing contract was formalized within a week. I hired Keith Bradley as my lead manufacturing specialist and brought Stephanie Parker over from sensor integration to handle systems testing. Within a month, we had a 12-person team focused on hybrid solutions that major contractors actually wanted to buy. 6 months later, I was reviewing production reports for our first commercial hybrid positioning systems. The numbers told the story better than any presentation. 99.7% uptime across all installations, 45% reduction in maintenance costs, and 0 network-related failures. My phone buzzed with a text from Stephanie. "Jordan, General Dynamics wants to discuss expanding their hybrid tooling order. Can you take a call at 3? I smiled, remembering the day Lance had destroyed my prototype in front of Rachel Stevens. Sometimes the best response to having your work demolished isn't revenge at all. It's simply showing the world what you're capable of building when the right people are paying attention. At 49, I'd learned that experience and persistence still matter in manufacturing. That proven methods combined with fresh opportunities can change everything. That the difference between failure and success often comes down to finding clients who understand the difference between impressive presentations and solutions that actually work. The hybrid manufacturing division now employs 28 people across 3 facilities. We've delivered systems to aerospace contractors in 12 states, with international orders starting to come in from companies who need reliability more than connectivity. Lance took a position with a smaller firm focused on AI integration. Industry colleagues tell me he's doing well enough, though his reputation for claiming credit where none is due has followed him. As for Brett, he stops by the lab regularly, clearly energized by work that solves real problems instead of chasing quarterly metrics. Yesterday he mentioned that the board is considering expanding hybrid manufacturing into automotive applications. Turns out there's a market for technology that works, he said with satisfaction. Who would have thought? The best revenge I've discovered is simply building something so valuable that everyone wants it. Success that speaks for itself needs no additional explanation.